Question 7.7 of the descriptive chemistry unit asks to give the chemical reactions for the following statements. Part A asks for the reduction of beryllium chloride to beryllium metal with magnesium as the reducing agent. The best way to approach this problem is to first write down the chemical equation based on what they're asking. We know that beryllium chloride and magnesium as the reducing agent is reduced to beryllium solid along with magnesium chloride. A few things to remember is that the oxidizing agent is the element that is reduced and that the reducing agent is oxidized. Or a better way to look at it is oil rig, where oxidation is loss of electrons and reduction is gaining of electrons, meaning that if something is reduced, it's reducing its oxidation state, or if something is oxidized, it's increasing its oxidation state. So back to the chemical problem, we know that magnesium is the reducing agent, also known as being oxidized. So we know, based on a couple rules learned from a few units before, that rule number 1 is that the oxidation state of a single element is 0. So knowing that, going back to magnesium, we see that its oxidation state is 0, and because it is oxidized, it increases its oxidation state as it goes to magnesium chloride. Similarly, looking at beryllium chloride, we see that it's the oxidizing agent of this reaction, and knowing that, we know that it is reduced. So if it's reduced, it's decreasing its oxidation state. It's originally based on rule number 3, that group 2 elements have a charge of +2, that it goes from +2 and then is reduced to the oxidation state of 0 based on rule number 1. Also, something handy to keep in mind is that rule number 2 states that the charge of a group of atoms, molecules, should be neutral. And so you know that in the end that all of your molecules are neutral, and that this reaction right here is the final reaction to question A. Part B of question 7.7 asks for the reduction of strontium metal with bromine. Because of the certain rule for group 2 alkaline earth metals, we know that for certain a metal plus a halogen equals a metal halogen solid. So automatically, looking at this question, we see that strontium is a group 2 metal and bromine is a halogen. So with strontium plus bromine equals strontium bromide. Part C of question 7.7 asks for the formation of slack lime from quicklime in water. Before solving this, we have to keep a couple rules in mind. And knowing that for group 2 alkaline earth metals, the reaction with water for only magnesium, calcium, strontium, and barium, that this is the general formula. Also keep in mind that the decomposition of carbonates follows this general formula as well. From there, we can see that limestone, also known as calcium carbonate with some heat, has a very similar reaction to the decomposition of carbonates, and so it forms quicklime and CO2. From there, just as the problem asks, we form quicklime plus water to form slack lime, which is also very similar to the reaction of calcium plus water. And with that, you get the overall reaction.